Good evening, everybody. Welcome to Modern Day Debate. Tonight we're going to be debating flat versus globe. And to get us started, we have Big Country, 10 minutes on the floor, and it's all yours. Thank you for being here, everybody.
Outstanding. Outstanding. Yeah. Thank you for the intro. So I know we started this earlier, didn't catch it. I'll just say it again. Um, for Ozien, thank you for letting me reschedule this. I was supposed to do it last Sunday, but then my whole family got sick, so we rescheduled that. Appreciate that. Thank you again. Thank you to Modern Day Debate for hosting again. And just to clear something up, as I had said in the last debate, I did misspoke when I had said that there's two types of spectroscopy. I just want to clear that up. What I meant when I said that is there's two classifications of spectroscopy. All spectroscopy can be put into two camps, either terrestrial, celestial. Maybe we'll talk about it tonight, but that's just something I wanted to clear up. So, ladies and gentlemen, hooligans and hooliganettes, fellow interlocutors, I stand before you today to argue in favor of the proposition that the Earth is flat and motionless. The appropriate axiom to start this debate from is that the Earth is indeed flat and stationary. And why is that, you might ask? Well, it is ubiquitously true that anywhere we may travel or live on this place we call Earth, we observe flatness and measure zero curvature. I can always find a right angle dependent on a flat Earth having a flat baseline. Plane surveying data necessitates this, and shorter measurements are far more accurate than long distance measurements. This assertion is rooted in the fundamental axiom that our senses and measurements indicate a stationary flat Earth devoid of any curvature, tilt, or wobble purported by the conventional spherical Earth model. Firstly, let us consider our own sensory experiences. As inhabitants of this place that we call Earth, we perceive no perceivable motion or wobble in our daily lives. There is no earthly test to determine whether the Earth is orbiting the sun, and when we walk, drive, or fly, we do not feel or sense any motion relative to a spinning sphere. Our surroundings appear steady and motionless, consistent with the notion of a flat stationary Earth. Apparently, NASA and even higher learned aeronautical schools also teach that the Earth is flat and stationary when applying their equations to reality. Now, these, of course, wouldn't be based on a paradigm that isn't real when looking at something like flight, specifically that when people's lives are at risk. I have some citations for that. Maybe we'll get to that later. Moreover, our observations of the celestial bodies above also align with the flat Earth model. Throughout history, navigators and astronomers have relied on a flat Earth framework to predict the movements of the sun, moon, and stars with remarkable accuracy. Ancient civilizations such as the Egyptian and Babylonians meticulously charted the heavens, laying the groundwork for navigation and timekeeping based on the assumption of a flat Earth. Furthermore, modern measurements and experiments continue to challenge the notion of Earth's curvature. Despite advances in technology, no experiment has conclusively demonstrated any curvature of the Earth over large distances. Even high altitude balloon footage and photographs purported to show curvature can either be explained by lens distortion, atmospheric conditions, or my favorite, just plain old deception. Of course, NASA has been caught lying, as well as other space agencies have faked their footage. The comical video we saw a few months ago when India claimed to land on the south pole of the moon was an awesome scene for anyone laughing at the clown world in which we call the globe model. In addition, consider the lack of observable curvature on large bodies of water, such as oceans and lakes. If the Earth is truly a sphere, we would expect to see a noticeable curvature when observing distant shorelines or tall structures across bodies of water. Yet, time and again, these observations yield no discernible curvature, further supporting the contention of a flat Earth. Not only the lack of curvature on the oceans, but the constant motion of what is claimed in the heliocentric model would be impossible to navigate when explorers first set out. My favorite nail in the coffin for the globe model is pressure without a container. The globe is what we are, the globe admits, excuse me, the globe admits that we are not in a closed system. There is no physical barrier between our pressurized system, the air that we breathe, and the vacuum of space above that. How can this be? Before I reach my conclusion, since I don't have a full 10 minutes here, hopefully tonight we will get to talk about satellites, the horizon, and gas pressure without a container.
You still
In
have
conclusion,
6 minutes. I'll just let you know.
oh, okay. In conclusion, the assertion of the flat Earth model, excuse me, the assertion that the Earth is flat and motionless is not merely a relic of antiquity, but a viable perspective supported by our sensory experiences, historical observation, and contemporary measurements. As we delve deeper into this debate, let us critically examine the evidence and engage in a rational discourse to uncover the truth about our world. Thank you.
No worries. I thought you might have figured you were getting close to the end of your time there, but no worries. Thank you so much, Big Country, for your introductory statement. We're going to kick it over to Ozien, but just to remind everybody, we do Q&A at the end of these discussions. So if you have a question for either of our speakers, you can put it into a super chat, and it will get priority and be read first. Once again, this is Modern Day Debate. We are a neutral debate platform hosting debates on science, religion, and politics. Sorry, and we hope you feel welcome. Ozien, you got 10 minutes on the floor. It's all yours.
Thank you, Ryan. Thank you, Big Country. I actually prepared for tidal forces and gravity, but that's okay. I'm going to just do it on my camera, and I'm going to get going right there. It still proves a globe.
The idea was to hang by a very, very fine quartz fiber a rod with two balls, and then put two large lead balls in the positions indicated here next to it on the side. Then, because of the attraction of the balls, there would be a slight twist of the fiber. It had to be done so delicately because the gravitational force between ordinary things is very, very tiny indeed. And there it was. And it was possible then to measure the force between these two balls. Cavendish called his experiment weighing the Earth. We're pedantic and careful. Today, we wouldn't let our students say that. We would have to say they're measuring the mass of the Earth. So there's a. But the reason he said that is the following. By a direct experiment, he was able to measure the force and the two masses and the distance and thus determine the gravitational constant. You say, yes, but we have the same situation on the Earth. We know what the pull is, and we know what the mass of the object pulled is, and we know how far away we are, but we don't know either the mass of the Earth or the constant, but only the combination. So by measuring the constant and knowing the facts about the pull of the Earth, the mass of the Earth could be determined. So indirectly, this experiment was the first determination of how heavy or how massive is the ball on which we stand.
To really understand tidal forces, we have to understand the fundamental concepts of force of attraction between two masses, which is gravity, the constant we just proved with the Cavendish experiment, times the mass of A times the mass of B divided by R squared. And then we have force equals mass times acceleration. Then we can do an equivalency. We can substitute the two equations together and get acceleration of planet A equals the gravity times mass B divided by the distance apart between the two squared. And that's where we get, guess what, folks? That's where we get the tidal forces from. So now we've got this fundamental concept to get together. We're going to discuss what is the tidal forces. Well, that's the force of attraction between the two. It's sort of like these forces are accelerating force of mass. As the particles that are closer towards the mass are going to accelerate quicker, and it creates a spreading effect of the masses. As each particle is closer, it's going to accelerate quicker towards the mass. And then you got what's called the Roche limit. So if something comes too close to the mass, it sort of disintegrates as it's orbiting the mass. And that's what happens with the Roche limit. It's pretty cool. And then as two masses orbit each other, it actually causes masses to slow and eventually tidal lock, as you see in this presentation here. So that's how the moon tidal locked, and this tidal force is what explains the tides on Earth. Okay, let's consider the universal law of gravitation, as every part of the moon's mass pulls every part of the Earth, governed by the inverse square law of gravity, which causes the Earth to accelerate towards the moon. So point A would accelerate to the moon faster than point B, leaving point B behind, or the water basically behind, but not much water, like a meter. So invisible outward force. It's a tidal force. It's sort of a fake force. It's not real. It's based on gravity, acceleration towards the other, for the mass, the moon. It's not inertial. So now let's consider point A. going towards the moon, sort of diagonal vector. And then point B going towards the moon, of the Earth towards the moon. And then we sum the two vectors, and it's basically downward towards the Earth, especially with the Earth's gravity when we actually add that. Anyways, and these all sum together to sort of squeeze and go towards the moon as they'll sum, sort of like anti-gravity, only along the Earth-Moon line overall. And then we also have the push of the Earth's gravity sort of pushing in, which is 10 million times greater than the effect of the moon's gravity. So you don't really get much lift from the moon. It's sort of about the squeeze. There's no lift. There's no stretch, right? Right? It's no lifted. It's not stretched. It's a squeeze. So lakes aren't big enough to really squeeze. You can't lift them because the moon's not big enough. It's not enough acceleration towards the moon. Not close enough. Not a big enough mass. So let's consider that. Let's talk about spring tides. So that's when the moon is aligned with the sun and causes large high tides in a periodic cycle twice a month, like that. And you can graph it out. It's very regular. And then you got neap tides, which are low high tides. They happen twice a month when they're 90 degrees apart. And it's very regular. Predict it. Now, when it comes to actual ocean tides on Earth, it's much more chaotic on Earth, just like weather. There's lots of other stuff going on, like the rotation of Earth, the axial tilt of Earth. You got heat, you got topography, you got continents, lots of other influences going on. Ocean depths, ocean width. You got 5 ophthalmic points in the Pacific, 3 in the northern basin, I think. Anyways, you got 15 across the world. Northern hemisphere, they rotate counterclockwise. Southern hemisphere, they rotate clockwise, just like you expect if the Earth was rotating on its axis. Now, they still work as if the moon, sun, still affect the Earth the same way we predicted with equilibrium theory. It still reacts with the neap and the spring tides just the same way. It's still predicted on the 24-hour and 50-minute cycle. It still explains these type of models from the satellites. It's just because of the rotation of the Earth and the shallowness of the ocean. Oh, by the way, the speed of the rotation of the Earth means that we don't get apodromic points around the equator because our oceans are too shallow and the tidal forces are not enough to be allowed to create apodromic points around the equator. There you go. Now we got much better satellites to measure and predict tides, and we're using AI research to predict the effects of climate change on our oceans. So we need to take a more critical role in helping to prevent climate change, CO2 emissions. So how does gravity affect ocean topography? Well, let's talk about the moon's gravity. Not only affects ocean water levels, when I'm talking about that, I'm talking about the tidal bulges, but also interacts with the ocean floor's topography and impacts tidal patterns and internal wave formations. It creates what's called tidal bores, which is a unique geographical feature. The tidal forces can lead to the formation of these tidal bores, which are waves that travel up rivers and bays. It could be really large waves too, and they go against the natural flow of the river. And we also get what's called internal waves and tides within the oceans themselves. These are due to gravitational interactions that contribute to the generation of internal waves along ocean ridges, They're influenced by both the moon and the sun, depending if they're 90 degrees apart or in line, and how much pressure it's exerting on the ocean itself. And so you can see in this video how they're squeezing along those ridges. And these complex cyclic movements, these gravitational forces create cyclic movements within the oceans, which are crucial for marine ecosystems and influence global
10
marine
seconds.
navigation and fishing industries. And it's also like a negative influence on global warming. It helps to keep the oceans cooler, but unfortunately, we're putting out way too much CO2, people. All right. Yeah. I just want to finish the CO2 part. All right.
No
So
worries.
that's it.
All right.
That was only like 9 minutes, but whatever. That's okay.
Well, I was gonna say it depends on when yeah. All right. We won't talk about it. So let's carry into our open discussion, everybody. That's exactly what we intend to do. But if at any point, due to the nature of these intros, I think it's been quite interesting. If you guys want to go into a cross-examination, either of our speakers can let us know. That could be fun. And also, if you're listening to this on podcast form right now, which they're all these debates are going to be uploaded to our podcast form within 24 hours, and you're wondering, why didn't I get a chance to ask a speaker a question? Subscribe to our YouTube channel if you're listening on podcast right now. And once again, Q&A at the end of this, so get your super chats in. I see a couple people already are in there, so it's going to be a busy time, guys. Let's have fun. So Big Country, I'll kick it over to you for to start our open discussion.
Yeah, thank you for that. Thank you for the intro there, Ozien. So you're talking about the tidal forces there, with the presupposed gravity, but you started with
No, I did
mass-
not presuppose gravity. I started out with proving mass attracted mass.
mass. Okay, mass attracting mass is the one
Yep.
that you want to defend tonight. Okay, can you
I
show
proved
me
it.
Can you
Yep.
show me an example of mass attracting mass in nature, please?
Yes. There.
Okay, that's not mass attracting mass.
Yes, it is. This is a mass, and the Earth is mass. This is an example of mass attracting mass.
So then in that experiment, how come the two balls didn't get pulled downward instead of towards each other?
And what example?
The example used for the Cavendish?
Why would they have to get pulled downward? They got pulled towards each other.
Because the mass of the Earth is greater than both of those.
Because they were on a torsion bar, so it was set up so they could swing towards each other to not be influenced directly by the gravitation of the Earth.
Okay, so you're claiming then that the gravity or the mass attracting mass experiment in Cavendish can only be demonstrated with the two lead balls on a torsion.
4 lead balls.
4 lead balls. Okay.
Well, the original Cavendish experiment used 4 lead balls. We've done several Cavendish experiment with gold balls. Actually, they did one with gold balls, but the original Cavendish experiment used 2 375 kilogram lead balls, and I believe 2 5 kilogram lead balls on a torsion bar. And Cavendish himself was like an expert in electromagnetism. So he wrote tons of papers about electromagnetism. So he ensured that his apparatus originally, not that we haven't done it tens of thousands of times since then, was set up to isolate for electromagnetism. But we also have another test that isolates for mass. It's called the Coulomb's test. You can actually buy the test to make sure that you charge the device. You can measure for FE. To measure the force based on the electrical charge, and you can neutralize it to see there's no charge attraction. So there's all types of tests you can do for the Coulomb's test or the Cavendish test.
So what I'm confused is your claim that mass attracts mass, right?
Absolutely.
Okay, so but that's 100 years old. So are you suggesting that
100 years old? What do you mean?
Well, mass attracting mass is an old ideology,
No,
right?
It's not ideology. No, it's a fact of nature. It's a law of nature.
It's not a law of nature.
What are you talking? It's not a law of nature. Absolutely, it's a law of nature.
So
who are you to say what a law of nature is? How did you decide what a law of nature is or not?
All right, we do have to cede some time over to Big Country there.
Oh,
Okay.
he's asking the question. I'm responding. So we're going back and forth.
Okay. So I weigh 160 pounds.
Yes, that's based
Uh,
on the newtons, which is based on mass attracts mass.
All right, just one second,
Okay.
Ozien. We have to let him follow his example that he's trying to make there, and then
Now, if I weighed 160 pounds, I weigh 160 pounds. Let's say somebody's standing a foot away from me weighing 200 pounds, and we both jump directly in the air. Shouldn't we land closer to each other if indeed mass attracts mass?
You do.
What?
Yes.
How could you even empirically prove that?
You're not going to measure the distinction because you're not going to have an apparatus that can measure that
So then you would. So then there's no way.
distinction.
There's no way to determine.
No, because the mass is, you could calculate it.
But you can't measure it.
You could calculate it. Yeah, you don't have a tool. Just like you have never measured flat because there is no tool, there's no instrument you can buy that has an error rate that can measure flat over any distance that you've ever measured. You have to calculate curvature based on the tools we've had. You never measured flat either. Never.
Yeah. Well, yeah.
Because the earth is curved.
No, we measure
tool?
flat because there is no curvature. That is a
What
measurement of flat.
What tool?
What
tool
tool
did you measure flat with?
I use spirit levels all the time.
No, that spirit levels measure level, not flat. What did you measure? Can you define level? This measure. Can you define it?
Yeah, it's off of a 90-degree axis.
That's level. Can you measure? Can you define flat?
Flat is level.
No, level would be there is no deviation in altitude across the surface. That would be flat.
No deviation in altitude?
Yes.
So flat
That'd be flat.
and level.
No, those are two different words. They mean two different things.
It's synonymous.
No.
It is.
No. How did you measure flat?
No curvature
Yeah, how did you measure it?
with the spirit level.
No, level measures it in one location.
Okay, so what do they use for plane surveying data then?
No, I asked you, how did you measure flat?
How did I measure flat?
When did you measure flat?
I've used levels. I've used.
When did you measure? No, that measures in one location.
Okay, so I've used level to
One
find
location.
to find a 90-degree axis point, and then gone to another location and measured a 90-degree axis point and pulled a string between those two, and there's no curvature in between those areas.
What's a globe prediction? How far did you pull the string?
Gosh, this was like a year ago. Man, 100 feet maybe.
And what's a globe prediction for the expected curvature over 100 feet?
Very, very, very marginal. Specifically, I don't know the answer.
Basically zero.
But not zero, right?
You would not be able to measure it.
Okay. Have you measured curvature?
Yes.
Where?
With my drone.
You measured curvature with your drone?
I'll show you 3 examples. Here's my drone footage on the top image there. There's the one that PBS did where they show the bottom of the flag disappearing. And there's somebody on the curved driveway showing where if you zoom in, just use the zoom lens, it doesn't actually cause part of the boat to change. But if you go up in elevation with this camera, it shows more of the boat appearing, which is what I showed with my drone footage. So that's how you can measure curvature.
Okay, so when you increased altitude with your drone?
Yep.
So wouldn't that increase your viewing capability?
Absolutely, around the curvature.
So you think that if you go higher, you're seeing around the curve?
Absolutely. That would be what was predicted by that geometric shape.
So how high would you have to be to see curvature?
A foot or 6 feet. You can see 3 miles at 6 feet.
So you can see 3 miles at 6 feet. So you're very aware then that the black swan observation falsified the radius value.
No, absolutely did not. That's refraction. Answers in Genesis debunk that.
How did they debunk it?
The same image, it's all refracted. Have you ever seen the Answers in Genesis review of the black swan fallacy? You know what Answers in Genesis is, right?
No, I'm not familiar with that at
They're
all.
the Christian organization led by Ham. He does the Noah, not the Noah's Ark, the Ark thing from Noah's Flood
I couldn't.
Museum.
Mm-mm.
The Anyways,
I
answers
think
to
you
Oh,
mean
Genesis.
I
you
think you
talking about
mean
Kent
Ken
Hovind?
Ham.
Ken
You talking about
Ham.
Kent?
Ken Ham.
Oh,
Ken
okay.
Ham.
I thought you were talking.
Yeah,
I thought you
Ken
were talking about
Ham
Ken.
easily refuted the black swan. That's just a fallacious argument. So that's all reflection. If you look at that, the arms are like wavy. Do you think like crane arms are wavy?
No.
And the further oil platform, half of it's still gone. And when you look at it on a clear day, they all lower. So, and it's expected curvature. One's like 6 miles, one's 9 miles away. Those oil platforms are tall, and most of the oil platforms are not observed. It's totally expected, calculated curvature for those heights of those oil rigs for both of them.
That is a very interesting claim that you
It's
made.
true. It's calculated. Use a curve tool. Measure it. Go do it
Okay.
yourself.
So you're talking about the refraction there, though. So what was the
Both of them.
refraction index for that day when that picture was taken?
It wasn't a picture. It was a video.
Okay, so the freeze frame of the video, what was the refraction index for that day of the video?
It was throughout a day. So there was different parts during the day. If you watch the whole video, the earlier part of the day was really badly distorted with a super heavy refraction index, which caused the images to be lifted, be discolored, super distorted, like orange and brown and stuff like that. You've seen the picture.
Mhm.
And then as the sun came up and the temperature got warmer. I think it was off the coast of Santa Barbara, right? In California, where
I'm
you're
fairly
from.
certain.
Yeah, I think it's off the coast of Santa Barbara. So, or you're not there anymore. Too bad. You could go check it out.
I hate
But
that state.
yeah, I left there too. Anyways, I've been in Santa Barbara also. Stay at a stinking bet. Motel 6 is like $300 a night. It's ridiculous.
Yeah, and there's dirty needles under the bed.
Yeah. Anyways, and later in the day, they're nice and blue, clearer, even though you still got like overcast. They're still refracted, so the light's still bent, so they're still lifted a little bit, but it's still not as bad as it was early in the day. So they come down, but it's still predicted by the gold model. You go to the Bislin calculator, you put in the refraction index based upon that day, based upon those weather conditions, and it comes in what you would expect for that observer height. Gold
Okay,
model predicts it.
Okay, so there's a lot to unpack there. So I'm not denying refractions in the video itself, or the still shot that we're all familiar with from the video of that day. I guess my question
There's
here
two of them.
is that in the model that you subscribe to, right, is the horizon a physical location?
It's two locations. So you have in geometry, the horizon is a bounding circle. It's a tangential line that is your limit of vision. It could be up to the mountains. It could be obscured by buildings. It's whatever's blocking. It's wherever the skyline meets any blocking observation. That's literally what it is in any dictionary. It's where the sky meets the horizon. So it could be a building in the way. That's going to be the horizon, right?
Right. Or
right?
the sky meets the ground.
It does, yeah.
Well, but if you have buildings in your way, I get what you're saying. But
yeah,
the traditional
it's
definition,
a bounding. Yeah, people always want to reduce it to like you're in a perfect position, like out at sea, and you can perfectly see. So it's so if you just remove atmospheric conditions, because when we do science, right, we want to remove any possible variables we can, so we can isolate the independent variable and manipulate the one independent variable, so we can do our test to determine what our expected observation, what the changes on the dependent variable would be, right?
Mm-hmm.
That would be science, right?
Mm-hmm. Sure.
So if we reduce, so let's pretend we're in a vacuum of space and we're just dealing with the sphere and a flat surface, right? Vacuum, like we remove all. You could do this in a vacuum chamber if you can make one big enough. We can do it in a vacuum chamber and just do small, like a small sphere, a little itty bitty small camera,
How do you
and then
make
just
how do you make a vacuum chamber on Earth?
you just low pressure, low
Well, but yeah,
pressure.
you have to put it in a
That's it.
container, don't you?
Yeah, low pressure. You pull a low pressure.
In a container.
Yeah, because you can't have a high pressure next to a low pressure.
Welcome to Flat Earth. I agree.
We don't have high pressure next to low pressure on the globe.
We do.
No, we don't. You're wrong. You're straw
No.
manning the globe model.
I'm
No,
not.
we have what's called a pressure gradient. But why are you derailing the conversation we're having?
I'm
We're
not
talking
derailing.
about IV and DV to discuss what we would expect on a sphere. You asked me what a horizon was, right? So let's stick to that, then we can go to pressure gradients.
Sure.
So the horizon would be no atmospheric condition, would be the limit of vision that I would expect to see. If it was flat with no atmosphere, I should be able to see forever, depending on my.
But now you're straw manning Flat Earth.
I'm not finished. I should be able to see forever, depending on my angular resolution of my vision. If there was no atmosphere, but we do have angular resolution of vision. I don't have perfect vision. Okay. But I'm talking geometric. So say we have perfect angular resolution on it. If it was curved, a sphere, we would only be, if we're looking at the shape of it, we'd only be able to see a circle around us, which is exactly what we see. Now we add atmospheric conditions. So we add another variable and we can test atmospheric conditions, right?
Yeah.
And we get refraction, like lensing effects. Now we've done another test. We've done both of these tests. We've controlled for the variables. We've adjusted the independent variable, tested the dependent variable, seen the changes, Earth to the globe. Now you want to go to the pressure gradient?
No, I'd like to respond to that. So you
Okay.
said that the horizon is two things, right?
Apparent and actual. Yeah.
Okay, so where is
Physical.
the physical location as the horizon is?
It's if the Earth was a perfect sphere, which it's not, and I'm
agree.
an observer, it is a tangential line from my vision that's a bounding wherever the tangent line. If I have a sphere, I have a sphere right here, close enough, and I'm an observer right here, standing on the top of the sphere. A tangent line would be wherever this touches going around the sphere. That would be the tangent line.
Sure. So mathematically, your model dictates that it is a physical location and cannot move from there.
No, I just said it's two things.
It can only be one. It
No,
can only
you're
be
wrong.
one. No.
We have two variables. We have geometry and we have optics. Did I not say we had geometry and optics? Geometry is one independent variable. Optics is the secondary independent variable due to atmospheric refraction. That you have to account for both independent variables to determine what you should see. So you have a physical horizon and you have an apparent horizon based upon both independent variables. So don't straw man my model. Don't tell me what I ought to believe, please.
I'm not straw manning your model.
Don't tell me what I
by
ought
any
to
means.
believe.
I'm not
please.
telling you what you ought to believe. You're
Okay.
straw manning what I'm saying. I never said, Ozien,
Okay,
you
then
must
continue.
believe this.
Then don't tell me what the globe model is because I know what it is.
Okay, apparently not, because you're unaware that the mathematics in your model dictates that the physical curve of the Earth is a location that you should be able to travel to that blocks things in the distance that can never move.
You're straw manning the globe model. I understand it better than you, so you're
Apparently
wrong.
not, because in
So
your
you're
model, they say that the physical curve of the Earth can never, ever be seen, ever, and it's only the apparent location that we will ever see.
Provide a citation about geometry that says there's not a geometric horizon and an apparent horizon.
Provide a citation that says what?
Yeah. Do you know the axioms for geometry?
No, I don't.
What's the axioms for a sphere?
I don't.
I
Tell me.
described them already. I described them in layman terms about a tangential line for your limit of visions for the horizon were,
Hmm. Hmm.
right? And I described refraction. So you have two independent variables. I described how you can isolate for both independent variables and how you could manipulate both independent variables, like build a vacuum chamber, put a little mini camera, look, turn it around, see where the horizon is in a vacuum chamber, add a really dense medium and see where you get, add water, see where you get an optical effect in the water and see how it refracts, lifts up the thing. If it does what you expect, oh, that's what we would expect on a sphere. If it doesn't, because that's what we expect. We know that's how optics works. We've done these experiments.
All right. We need to give Big Country an uninterrupted minute to respond.
Sure, thank you. So once again, your model dictates that the math says that it's supposed to be at a specific location. It is not, because the horizon is only one thing, and it is an apparent location. It is apparently where the sky meets the ground, or the water, or the skyline, or what have you. Now with that, right, you would obviously agree with me, I hope, that when you look down the road and the street lights are appearing to converge to one another, they're not actually doing that, correct?
You're lying about my model, so I still have to address that.
I would never lie about your model.
We still
You
have
just
15
did,
seconds,
so.
so we'll give you the last. Well,
He asked me a question.
No, go ahead. Go ahead. Yeah,
All right,
James,
yeah,
that's
let's bounce it
fine.
then.
That's fine, Ryan.
Sure thing. If you want to respond, just because I have noticed that there's a little bit more response coming from the other side, but yeah, if you want to respond, Ozien,
He asked me a question. He's trying to interrogate me, which is fine. I don't mind.
no worries,
But
buddy.
when you're talking about street lights going up a hill, okay, we'll pretend they're going up a hill.
Why do they have to go up a hill?
So
Just
you
straight,
got
just straight road.
no. There's no such thing as straight because we don't know. Yeah, no one goes straight. They only go forward. Um,
Okay.
that's a joke from when I was a
Okay.
kid. Anyways, you never go straight. You only go forward. Anyways, so let's pretend they're going uphill. You have angular resolution, so things get smaller on the x and the y axes as they get further away.
But they're not. You'd agree that they're not actually converging. It's just an appearance, right?
They get smaller on the x and y axes.
Apparently, they're not actually physically getting smaller.
No, nothing gets smaller. Now when they go faster than you or slower than you, technically, general relativity, they get smaller, but you don't see that.
General relativity?
Yeah.
Are you aware that Run Zukao disproved that in 2015?
No one's ever disproved general relativity.
How did they prove general relativity?
Eddington experiment, LIGO.
Well, let's talk about Eddington.
Every
How about we
single
talk about
observation
Eddington?
we've ever made through
Every single
GR.
observation. Okay, so
The
how many
only
plates?
problem we have is dark energy and dark matter, but so those are placeholders. So we have the observations we have to find explanations for.
Excuse me. So how many plates did Eddington use in his experiment?
I don't care. We've done other tests since Eddington.
You invoked it.
Eddington was the first experiment. That's just a description of gravitational lensing around masses. That's what we saw with dark matter. So we've done tons of gravitational lensing since Eddington. That's just the genre of tests that we saw during an eclipse. Hey, let's see if they did one during the last solar eclipse. You want to see?
We could definitely, yeah. We could also see if they actually filmed it from space, but that's a place that doesn't exist. But concerning the Arthur Eddington experiment, I asked about how many plates he used, and you said you didn't care. Is that because you don't know? And that's okay.
Just let me review
I
my
don't
own
know,
screen
and
share.
I don't know because I don't care. Because it's not relevant, because I know we did the experiment and we know that we've done it 100 times since. Like we've done it several times since. They do it all the time.
So Arthur Eddington used 30 plus plates when he did the experiment. All but
Mhm.
two he was able to use as evidence for the lensing that they saw when they took the photograph. However, those two lenses that he used were also damaged. And then let me ask you this about the experiment. Did it match the prediction?
I'm not sure. Yeah, it did match the prediction. Last time we did the editing. So if we've done it in the last 5 years, we're just going to use that result, right?
Sure. We can use that result.
Yeah.
That's fine.
So
with me if you wanna pull it up.
1973 is the last paper I see. NASA ADS. There we go. The perfect opportunity arose on 21 August 2017. It was possible for ordinary astronomers to test Einstein with simple off-the-shelf equipment.
Darn
We
it.
ran a modern Eddington experiment from Casper, Wyoming. We used this S-Big STX 16803 CD camera along with the TeleView MP101. So people are doing this from home now. After experiments, it was decided to run without any filter. The plate scale was near 382 inch per millimeter. The pixel size was 3.4 inches, and the field of view was 3.9 degree by 3.9 degree. We obtained 39 1-second images of star fields centered with substantial shifts between images in the dark sky 7 hours before the eclipse. For the purpose of mapping out optical distortions and CCD imperfections, the system was untouched until the eclipse was over. During the 146-second totality with sight cirrus clouds, we obtained 11 eclipse images with 1.5 second exposures, showing over 60 stars from 53 inches to 155 inches from the sun's center. The analysis is currently underway. Effects to be corrected for include differential refraction, proper motion, parallax, optical distortion, and tangent plane. Final results should be completed by the time of our meeting. I don't know where
We'll
the
have to
results
wrap
are,
up
but
that ththought if you don't mind there, buddy. If you
Yeah.
wanted to.
Sure, I guess so.
So just yeah, go ahead there, Big Country. Sorry.
I was just gonna say, so the conclusion is one, we don't know because we haven't finished the results there yet. But in Arthur Eddington's experiment, just so anybody they can look this up themselves, it did not match the prediction. They said it was close enough to use, which is a problem.
no, it's not a problem. Why is it
How
a
is it?
problem?
Because it didn't match.
Do you ever worked in a trade?
Yeah,
Do you have a metering error?
of course.
So if things are within the meter error, is the result good?
Yes, but that's an
There you go.
actuality.
So the tests they do are in actuality.
No. Okay, so let's unpack that real quick because I am in a trade. I'm a journeyman inside wireman. So
Oh, good. I was a substation test technician.
oh, there we go. Okay, so there's some common ground here.
Well,
Um,
commissioning engineer actually,
um,
but whatever.
so when we make a prediction in the electrical field, right, we do a sorts of calculation, load calcs and different things to
Yeah.
expect a specific result. Now, when dealing with electricity, if
You could
any
be 20%
electrician
off.
if any electrician is worth their salt, they would be willing to admit that we have no fucking idea what electricity is. We know what it's composed of, we know how to harness it, we know how to control it, manipulate, distribute it, but what is electricity? No clue. We have no idea what it is. Now, the margin of error that we would be willing to accept with a load calculation is extremely minuscule.
Huge.
Well, that we'd
Huge.
be willing to accept?
So how much do you overrate a circuit breaker for a circuit?
Overrate? Well, it just depends on the breaker.
So if you have a 20 amp load, what size breaker do you put in?
A 20 amp. I'm sorry.
For
say that
the
again?
fault. So say you have a 20 amp circuit, what would the typical fault duty be for a 20 amp circuit?
Is anything over 80%. Yeah, anything over 80%, we would consider too much of a load on that.
So what
breaker.
would be the trip for like a 20 amp breaker? Like you'd put like 300% for 1 second is like the typical trip time.
Yeah, it would instantaneously trip for the most
It
part.
depends on the breaker. Anyway,
It
doesn't
depends
matter.
on the breaker, but yeah, I understand what you're saying.
All right. It doesn't matter. I do testing. So
All right. I just
different
wanted
side.
to inject.
Hey,
I was able to hear you,
we're a
even
flat
though
earth.
I was having a moment there just off scene. Just to remind our audience how this ties in. And also, I want to tell you guys,
Airs.
Ozien, Big Country, we have 500, almost 540 people watching right now, and only almost 70 likes. So,
Come on.
yeah, if you guys have fingers or like, appendages that have heat, like, hit the like button. It's super simple. I've done it with my nose. All right, come on. Let's carry on, though, fellas.
So
And also remind our audience how this ties into our subject, if you
well, I
can,
do want
or if you're just having fun.
no, I do. We need to get off this, but we do have measurement error, metering error, measurement error. Even your fluke has a metering error.
Sure.
Your fluke is like an ohm meter, voltmeter, current meter for the people that don't know. We often call it a fluke.
Mhm.
You said your axioms of your axiom of senses.
Mhm.
Do you think like your touch taste like is an axiom? What do
I
you
think
mean
it's
by that?
well, the appropriate axiom for what I said was the appropriate axiom for the debate is that the Earth is flat and stationary because all of my senses tell me that it is. I can't measure curvature. I don't sense rotation. I don't sense orbit. The celestial bodies in the sky appear to be moving above me. They move in such a way that we use them as a map and a clock. That's what I mean when I say that.
What type of motion like you're not Iron Horse, I assume. But anyways, what type of motion would you expect to sense?
I'm sorry, say that again.
Like would you wouldn't expect to sense like a linear like just traveling down the interstate at 60 miles per hour, right? Like not change of speed. You would expect to sense a change in speed, right? You wouldn't expect to sense.
Well, sure, yeah. Mhm.
Okay, good.
Yeah, I
So
would agree with
like
that.
the Earth is not traveling very fast. It's not changing speed very fast. Would you
Well,
agree?
according to modern cosmology, the Earth speeds up and slows down all the time.
But not very quickly.
It's irrelevant.
So imagine turning your car going around a 360-degree, what do they call your turn
Like a roundabout?
roundabout. You imagine you go around a roundabout and you spend 24 hours going around at one time.
Hmm.
Like, would you feel that motion as you go around the roundabout in 24
No,
hours?
in 24 hours, no, I definitely would not assume that
Well,
I would feel that motion.
that's what the Earth is doing every
So
day
it's going a roundabout
in
one
24
time
hours.
in 24 hours
Yes.
while wobbling and shooting through the ever expanding space
Even
at 1 million
slower.
miles, at 1 million miles an hour.
But it's going straight. It's not moving.
It's wobbling.
It's not, it's, it's not moving fast. It's slow. So it's not changing. It's not like it's going, it's going like glacially slow.
Okay. Is there
But
any test that you could actually prove that we are moving?
yeah, yeah, several. Besides going to space,
I don't think you want to go there in this debate.
ring laser gyroscope, Foucault's pendulum, all types of tests, star aberrations, oh, what do you call it when you see like the old meters? You have the deflection between the meter and the back.
I'm not familiar with that one.
We use it to see the stars. Like somebody in the chat will fix me, like my brain. I get brain fart. It doesn't matter.
Sure.
We got ring laser gyroscopes. We got Foucault's pendulum, and then we can measure the stars, and we can see that we're moving in relationship to the stars.
So with the ring laser gyroscope, would it be an issue if at the same latitude at a higher elevation, the speed would be different?
It's not though.
It's not.
Yeah. Do you have any Is it outside of the tolerance of the meter?
So I know this is such a point that they use. They're like, oh, it's just a malfunction of the tool that we were using. But how would you explain the extra energy that would be added for that increase in speed?
What increase in speed? I'd have to see your results. Do you have test results?
I don't have a result to show you.
Well, then how do I know it's even true? Because they are affected a little bit by temperature and a little bit by they have an error. So it's not affected by altitude really, but the further you go in altitude, the more I'm not sure if there's any difference really in movement, but I'd have to think about that more. But
Okay.
yeah, they shouldn't be changing in you go in altitude. But they do have error. There's metering error in ring laser gyroscopes. They work within a certain range.
So it would be just a metering error, in your opinion.
If you look them up, they give the list is like plus or minus so many degrees, like point whatever degrees, and everything I say will say that they'll put the errors there.
Well, sure, I'm not denying the metering error there, but
you know those have you ever worked in a substation?
mm-mm.
Well, we had panel meters, right?
Mm-hmm.
So the old panel meters were like some of them were 1% meter error,
Mm-hmm.
and they were 2000 amp meters. A 1% meter error was plus or minus like 20 amps. So even that's how they were. So even at is it 20? No, maybe they were 5% meters. So 5% of 2000 though. So 0 to 2000, 5% error. So that's like 100 amps, right? 100 amps.
Mm-hmm.
So they were plus or minus 100 amps. So if it says 0 amps, it could have 100 amps.
Sure.
You don't know because it's plus or minus 100 amps. I'm just saying, like, but that's old school, like, stuff. And the ring laser there's another thing. Ring laser gyroscopes weren't really invented until after Einstein died too. But those do measure rotation.
Before we compound too many things there, yeah, we got to give Big Country a little bit of space here to respond, just because we have given a lot of space for you to speak their Ozien. So, Big Country, I want to give you at least up to 2 minutes here to kind of give your thoughts on where a discussion is going and what you think of everything so far.
Well, Ozien, why don't we change gears then? And you said we could talk about gas pressure without a container. We could talk about that.
Absolutely. Where's the container between the gradients?
Are you suggesting that you can't demonstrate a gradient in a container?
Yeah, I've never seen a gradient in a container.
So if I were to have a container and then I put in, let's say, sulfur hexafluoride, it's a heavy gas, it would sink to the bottom. And then I put a less heavier gas in the container, it would sit on top of that. And then if I put a less heavier gas on top of that, then that would sit on top of that because it would seek its equilibrium in the container, right? So there would be the pressure gradient in the container.
Why would there be a pressure gradient?
If
it's a pressurized container, it should compress the other gases that are on top of it.
Oh, the gases are pressurized because they collide with the edges of the container.
What?
Yeah.
No. Who said that? How did you test that? How did you measure the pressure in the center of a container? No. The pressure gauge is a little gauge for a container goes into the middle of the container. It doesn't measure the walls. Pressure, you've seen a pressure gauge, right?
I sure have.
Yeah, the pressure gauge is in the middle of the container. It doesn't measure the walls.
Okay.
What are you talking about?
Let me say this here.
That's right? The pressure gauge goes in the middle of the container, right?
Sure.
Okay, good. We agree then.
I agree that there is a pressure gradient in a container that can be demonstrated.
How did you measure the pressure gradient? Do
you want me to give you a citation?
In a pressurized container, you measured the pressure gradient?
Okay. Let me say this. For the statement regarding a pressurized system that cannot exist next to a vacuum without a physical barrier, the second law of thermodynamics provides essential insight. This law fundamentally states that heat naturally moves from a region of a higher temperature to one of a lower temperature. This means that a pressurized system like Earth's atmosphere can indeed coexist to a vacuum like outer space, but only when there's a barrier preventing the high pressure gas from dispersing into the low pressure vacuum. Without such a barrier, gas molecules would disperse freely into the vacuum until reaching an equilibrium state where pressure equalizes in both the pressurized area and the vacuum. That's from Encyclopedia Britannica.
Ask for an example of a pressure SF6 tank. If you, I don't know if you use FS6 tanks or nitrogen tanks, fill it half with SF6, fill it half with nitrogen, and pressurize it with nitrogen to 80 psi. The whole tank is going to be 80 psi. The SF6 will be 80 psi. The nitrogen will be 80 psi. And when you put the probe in, it's measuring the middle of the tank, not measuring the wall. Whoever told you that pressure is against the wall misinformed you.
Mm-hmm.
I don't know who told you that. The molecules are pressing against each other.
And the
Like
walls
you
of the
understand
container.
states of matter, right?
And the
when
walls
you
of the container, right?
What happens when you compress gas? Have you worked with like nitrogen bottles?
Mm-hmm.
What happens when you overpressurize a nitrogen tank?
It gets hot.
What happens when you leave it alone for a while when it's
Cools off.
overpressurized? It cools off. It gets cold, right?
Mm-hmm.
Does it become liquid?
I don't know.
It can. It becomes liquid.
Yeah, I think depending on the
Yeah.
circumstances, yeah.
If it becomes overpressurized, it can become liquid. And so how does a gas become a liquid if the molecules are not pressing against each other
And the
and
container.
only pressing against the wall? So it's not just pressing against the wall of the container. Is that correct?
Say that again.
So the nitrogen molecules, the nitrogen atoms that exist, right? We agree they're atoms. They're pressing against each other and the wall of the container. Did we agree?
Agreed.
Okay, good. Because you said they only press against the wall of the container at first.
Okay, I might have misspoke there. Yeah.
Okay, so we're clarified on that because a lot of flat earthers will say because they do that experiment of the rocket in the vacuum chamber and they'll claim it has to press off against the wall. That's obviously not true, right? We know that a rocket can work in a vacuum, right?
No.
What we just explained it just now that
Ozien,
the molecules.
Ozien, can you just answer the question for me?
I thought we just explained that the rocket
No.
can work in a vacuum.
Can you demonstrate to me pressurizing gas without a container?
No. The pressurized gas.
I agree. Welcome to Flat Earth, Ozien. You finally showed up.
To pressurize gas at a constant pressure needs a container, but we live in a pressure gradient.
Okay.
That has no container between the gradient.
Okay, but what is the necessary
that it goes from one
for gas to be pressurized?
It goes from 1 atmospheric pressure to 0 atmospheric pressure.
What is the necessary antecedent for gas pressure to exist in the first place?
Nothing.
You just said you couldn't do it.
To have a constant pressure, you need a container. But we live in a pressure gradient.
Okay, can you pressurize gas without a container? Yes or no?
To have a constant pressure, you need a container.
So the answer is no.
We live in a pressure gradient, though.
What is the necessary antecedent for a pressure gradient?
What is an antecedent? Can you describe it for me?
It's the prerequisite.
There is no prerequisite for gas.
For a pressurized gas, you just admitted that you cannot do it without a container.
Can you describe it? What's the world we live in? Does it go from
a flat stationary plane?
No. The gas pressure, does it go from 1 atmosphere pressure to 0?
Does it what?
Have we sent weather balloons up where we've measured from 1 atmospheric pressure to 0 atmospheric pressure?
We sure have.
We have. So what's 0 atmospheric pressure basically?
What do you mean? What is it?
What's 0 atmospheric pressure equivalent to with a weather balloon?
Equivalent
at
to
62,000 kilometers, at 62 kilometers, or at
what's it
62 miles up.
what's it equivalent to?
Yeah.
A low pressure system?
No, like jets can't, like jet planes can't fly above 62 miles, right? You agree with that?
Why not?
Because there's not enough atmosphere pressure, because it's
Right.
basically zero,
Okay. So
because it's basically a vacuum at 62 miles.
it's not basically a vacuum.
It is a vacuum at 62 miles.
Okay, but you've already admitted that you can't produce what the globe model claims it to be.
It's zero pressure. It's basically zero psi, almost zero psi at 62 miles. That's why planes stall out at 62 miles. Why do planes stall out at 62 miles?
I don't know, dude.
Because it's
I'm
zero
not a pilot.
pressure.
Okay.
I
So
was an aviation electronics technician in the U.S. Navy for 11 years, first
Thank you
class
for your
petty
service.
officer. It's like they can't go the deck for aircraft jets 62 miles.
Okay.
So
I'm
we
not
live in
sure.
a so vacuum of space is basically considered 62 miles, 100 kilometers,
That's the Kármán line.
Kármán line.
Okay. So this is funny.
Planes can go there. Planes can fly up there.
To where? Space?
Yes.
The violation that we just talked about
What violation?
of the second law of thermodynamics.
No, that's zero pressure. They fly up there.
They fly up past the Kármán line. Is that what you're saying?
They fly up to zero pressure. Yes. They measure it on their indicators with their barometers. Yes. They fly up with their barometer. We're zero
And they go
on
into
the
they go into
barometer.
outer space.
Well, we call it outer space. Yes, where there's zero
The
pressure.
vacuum next to the pressurized system.
What's a vacuum to you? I think you're just misusing the word. I think you seriously are. What's a vacuum to you? I call it 62 miles. What do you call it?
I call it a container.
No. So a vacuum is just a low pressure system. That's it.
Okay, so are you suggesting then that the Earth, the gases that we breathe here are not escaping into the available volume, which we know
They
that
are.
they do. I just gave you a citation from Encyclopedia Britannica that said that could not happen.
They are.
They would all fill the available volume.
No, not all of them, because gravity.
Okay, that's where we need to go then.
I already proved
Pressurized
gravity.
gas without a container using only gravity. Go.
It goes from we have an observation.
Not what I asked.
I don't. We have a downward acceleration. We have an observation of 1 atmosphere. You know what 1 atmospheric pressure is, right? That's sea level. We call it 1 atmospheric pressure, 4.7 psi. Just simple concept. Some people get pedantic with me when I say 1 atmospheric pressure. That's 14.7 psi, sea level. 2, zero atmospheric pressure, which is 0 ATM. So from 1 ATM to 0 ATM, which is the Kármán line, that we have like the Blackbird or whatever that can fly up to like 70 miles, that can go above, that can fly to what we call space.
Mm-hmm.
We have Air Force pilots that can fly to space in aircraft.
Mm-hmm.
That can fly to space in aircraft.
Mm-hmm.
That can go to zero pressure. That can go to the vacuum of space.
Mm-hmm.
In jets.
Mm-hmm.
In the pressure gradient. We send up weather balloons that can go there and measure that this actually exists. You can do it yourself. You can measure a pressure gradient. So where's the container?
Are you done with your monologue?
And where's the container between the gradient?
Can you answer the question?
Where's
Can
the
you
container?
pressurize gas without a container
It's not
using
pressurized.
only gravity?
There's no pressure at the Kármán line.
There's pressure down here in there. You said it was because of gravity. So pressurized
Where's-
gas without a container using only gravity.
Where's the container at top of Mount Everest? There's no container.
Okay, Ozien, your hand wave dismissing my question. Your claim was that the air we breathe down here that is pressurized is due to gravity. So
It's not
test it.
pressurized.
The air we breathe down here is not pressurized.
No.
What?
What do you consider? It's not pressurized in a container. We don't live in a container.
We do. It necessitates a container.
No, that's a lie. Who told you that?
The fact that you cannot produce the claim that you just made is a big giant L for you,
No.
my guy.
Somebody told you a lie. There is
You
no
just
antecedent.
You just said to everybody watching, 500 something people watching right now,
Yeah.
gravity pressurizes gas that we breathe down. That's what holds the gas down here. Please test that.
No, there's
Show
a
me the
downward
test.
acceleration. I'll
Show
test
me the
it right
test.
now. There's a downward acceleration.
Where?
Right?
Okay, that one that you just dropped is not gas.
Okay, here's a cross. Here's a cross.
I don't care what you drop. It's not gas.
Does gas have weight?
Yes.
Does gas fall?
Yeah, sometimes it depends on the gas. Because gas is omnidirectional.
Does gas have a downward acceleration?
No.
No. So SF6 has no downward acceleration.
SF6 does not have a downward acceleration.
If I pour SF6 down from my ceiling, will it have a downward acceleration?
A downward acceleration?
Yeah.
It'll seek its equilibrium.
Just like this, right? It'll seek its equilibrium. My cross instead of my wand.
Look, dude, my guy, everybody just saw that you cannot produce what you just claimed. It's fine. We can move on.
Because there's no. Where's the container at? Can you tell me where the container is?
No, I've only been to like 6 states and Ireland one time.
All right. Just to inject right quick here, gents. Big Country, you said you wanted to move on, and I'm
I'm not ready to.
Well, I just want to ask, Big Country, did you have another subject that you wanted to move into, or did you were you suggesting you wanted to get into the
I want to know
Q&A?
about tides.
We could talk about satellites if you wanted to.
I want to know
Sure.
about tides.
Well,
How do you
let's-
explain tides?
All right, here's what we'll do. Just for the sake of being fair here, just for who's gotten the most time to speak, let's do another 20 minutes. We're going to do 10 minutes on satellites first, 10 minutes on tides. All right, so Big
Okay.
Country, you first.
Okay, satellites. Satellites are an interesting one, only because the idea of a satellite, of what they claim it to be, one, it exists in a place that I just demonstrated cannot exist, for one. Two, satellites exist in the sense of attached to weather balloons. Those crash a lot. However, if you were to go on, anybody can do this right now, go to Google or whatever search engine you use and just type in space junk or satellites from space. All of the images that you will find will be CGI fake ones. But we know that satellites are not used for worldwide communication. We know that. 99.99% of all worldwide communication is done through underwater sea cables, fiber optics, radio towers, different things like that. But the materials that satellites are built from are claimed to be built from are built from materials that cannot exist in the place that they say that it does solely on their own admission. Right, so Kevlar is one that they use, and that has a melting point of 930 degrees Fahrenheit. Aluminum has a melting point of 1220 degrees Fahrenheit, and carbon fiber polynane doesn't melt, but it does turn into gas at 6,254 degrees Fahrenheit. So the thermosphere is where they claim that most of them are. Has temperatures of 2,730 degrees Fahrenheit. So essentially, all the material that they are made out of would fail. And Ozien, I think that you'd be willing to admit that there's some problems with just the mechanical aspect of them. With being an electrician, especially on a DC system, we would know that the requirement for a ground to be involved in that system is pivotal to its operation, not because it would cause it not to operate if it's not grounded. However, if there was something similar to like a solar flare that the globe model says that will cause communication errors, but it would also produce a large EMF, which would completely destroy the system if it's not properly grounded. And of course, satellites are not grounded in any way. So satellites do not exist in the way that they say that they do. They do not exist in the place that they say that they do because they can't. And we know that fiber optics is used for all worldwide communications. That was pretty quick, right?
Yeah. DC systems. So I have electromechanical engineering degree. I am a commissioning engineer, protection and control, basically. DC systems definitely do not need to be grounded. And I think you meant electromagnetic pulses to shield it. They just need to be shielded and has to have a reference. So they don't have to go to earth ground to be shielded from an electromagnetic pulses, but that's about volts per foot. And so any volts per foot can be overcome by a big enough electromagnetic pulse. So you can only shield for so much of electromagnetic pulse. So that's not an issue. That's always going to be an issue. I'm more worried about our transformer systems from a solar flare from the sun that exists 93 million miles away. Problem with thermosphere, the density of the molecules that exist, because there is a partial atmosphere, because a vacuum doesn't mean there is nothing. Vacuum always has a pressure because there is no lack of nothing in space. There is always fields, matter, or gases everywhere in space time that exists. There's never nothing. Nothingness is a concept that is incoherent to me, at least maybe outside the boundary of the universe, but then we're talking about incoherency. So thermosphere, that heat you're talking about conductance. So if you or induct, like the transfer of heat needs to be between molecules. So if you know anything about heat transfer, if there's no atmosphere, it can't heat up the satellites. So you should know that. Like,
so, but how do you quantify
and
that,
then,
Ozien? How do you quantify that? Like,
well,
to say
like
that
you had two more claims. You said most fiber optics are most communications through fiber optics, but yes, most
99%.
terrestrial communications through fiber optics. Satellites are used for a lot of other stuff, like my dish outside for television. There's dishes over the equator, so people can work on dishpointer.com and point to that dish, to that satellite that's over the equator, and it will only work if the Earth is a globe. You can point to it from the equator, point versus somewhere in America, point to somewhere in South America. You can prove the globe by pointing at the satellite. I wish I had the thing. I could press a button right now and show you my little video clip. I don't have it set up right now. And also GPS. As a commissioning engineer, I had to sync to GPSs. I had to sync to at least 4 satellites in orbit. Nowhere near any towers. Balloons won't work. They just won't work. They fall out of the sky. You need reliability. I need synchronized time. Nothing else would work except to have satellites that are away in orbit. You need at least 4 of them. And usually I got 10 signals. And now ask me your question.
Okay, so back up to the temperature of the, was it the troposphere?
Thermosphere.
How do you quantify that? Like, how do we quantify the idea that the measurable temperature up there is 2000 degrees Fahrenheit, but it actually does not have enough energy to produce that temperature, so the temperature is 0? Well, that wouldn't be 0 because 0 is a temperature.
Mm-hmm.
So how do we quantify that? It's I understand what you're saying, but how do we quantify that?
So heat is through conduction, so heat transfers through conduction, radiation, and convection. It's measured through the I want to say vibration. It's not vibration, through the activity of the molecules. So the molecules are active because they're absorbing radiation from the sun. So the sun is irradiating them, they're active. So those molecules are just active. So it's hot in that regard. So if you were up there exposed to the sun, you would burn, right? That's why when we went to the moon on the Apollo mission, we actually did what was called a barbecue roll. So the command service module, when it went to the moon, actually did a barbecue roll.
They did.
They actually
went golfing. They did it all.
They actually rolled the command service module so it would evenly cook the command service module as they went to the moon. So they weren't exposed. One side of the module wasn't exposed to the moon or the sun, excuse me, because the moon is not a source of heat. Only the sun is. As they went to the sun. I don't know how you explain how you keep the earth warm in the prison world you think we live in. Max, you're watching this. Where's my music video I made? Anyways, get it done. Sorry, somebody else.
Yeah,
what was the next question?
Ryan, how much time do we have left in this 10-minute segment here?
You have, let's see here. 2 minutes left, actually. 2 minutes and 15 seconds.
So real quick to the fiber optics, back to the fiber optics. So we know that it's 99% of all worldwide communication is transferred through fiber optics. Now that's not just voice and data, but that's telephone and everything else. So the idea that satellites would exist for data transfer, even based on an economic, for like an economical argument, it wouldn't make sense because a wireless signal is always slower than a hardwired signal, especially when you're
Sure.
For fiber optics. Fiber optics is the future. They're starting to port fiber optics into basically everyone's home. I have 2 gigs of fiber in my house. But the idea that GPS is utilizing satellites, can you expand on that at all, Ozien, last minute we have or whatever?
Yeah, so when I worked on, so we have like line differential relays. They had to monitor the 3-phase power system at both ends, say like 100 miles or 500 miles apart in some cases for like I think there was a DC line in California, it's 800 miles apart. But anyway, so say like 100 miles apart. And we have like a direct fiber cable, but we have to send signals to the fiber cable.
1 minute.
They have to be timed. And so we have to use a GPS clock. And by clock, I don't mean like 12 o'clock. I mean like a pulse signal, right?
Right, to keep it in phase.
Poop, 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 poop. To keep the currents in phase to come on at the same clock time, 60 hertz time, and 100 miles apart. So we have to have both test sets come on at the
30 seconds.
precise moment. Well, we still have, we're going on a different topic. I can give up some of my time.
Fight for it like you want.
Come on at this precise time. So they have to be able to sync with 4 satellites in orbit to get this GPS time. And we could be up in the mountains and where there's no cell service anywhere, no landlines anywhere. So yeah, I agree with you. We don't need, like, we're not using satellites for communication really, unless we're in remote places where I have been, where I've had to use satellite phones with a stupid large antenna out there because I've worked in remote places where I've had to use sat phones.
Gotcha. So how do they sync the times with a satellite being in outer space?
We had an antenna that I would have to put away from a building. If it was too close to the building, it would create a shadow sometimes. So I'd put it like 4 feet away from the building so it could get a line of sight up, like
10 seconds
up.
for you, Ozien.
And then I get like 10 satellites and you need at least 4 satellites to be able to get time.
All right. So we're going to move on to tides. Ozien, this is the talking point you wanted to move into. So we got 10 minutes on the floor, and I'll let you start us out. Go ahead, Ozien.
Yeah, how do you explain that tides, almost all tides in the world for the oceans, like there's no tides in lakes. A lot of people misconfuse, like they think the Great Lakes technically have like high tides that are really small, but the normal weather patterns override the tides that are experienced. But how do you explain that the tides we see on Earth are synchronized to the moon and the star and the sun? And we have the Cavendish experiment that isolates for mass, attracts mass. It's separate from electrostatics, which is the Coulomb's test. We have 2 experiments that isolates for the independent variables, those 2 different variables. And you can do those tests. I recommend you do those tests, especially as an electrician. You know the safety rules. How can you explain that the like I can explain tidal forces. I can explain it based upon these concepts, why the tides work so well based upon the equilibrium theory and the dynamic theory of tides, the synchronicity, the periodicity, and predict tide. We can predict tides based on the satellites in orbit to within centimeters.
Mm-hmm. So my best approximation of an explanation, because you gave an explanation and that's great. But of course you didn't demonstrate it because it cannot be demonstrated. Like you can't pull a tide in like a pool with manipulating a gravity of any kind. My best guess or theory, I could say, of what it is I think that I would believe that there is some type of electromagnetic force, but that's being exerted from the sun and moon to the oceans, and it's being extrapolated exponentially because of the salt content of the water. Because we know that salt increases the electrical field within water, which is why that would explain why lakes do not have tides because there's no salt in them, especially freshwater lakes, swimming pools, things like that.
But water is diamagnetic. Salt water and water both is diamagnetic. So if you're talking about just electrostatics, yeah, water is pure water is not conductive, but even lake water is considered briny. It's not pure. So lake water conducts. You're an electrician. You know it's not pure. It conducts, right? So you know these people, they say, oh, lake water doesn't have tides because it doesn't conduct. You know that's not quite true. It's pure water doesn't conduct. You're the electrician. So that doesn't explain lakes, right? Like, so, but oceans, you're right. They got salt, but salt water is diamagnetic. So if you know anything about electromagnetics theory, if you deal with electromagnets and you deal with, so Lenz's law, right? Aluminum is diamagnetic, which means it resists the influence of electromagnetic forces. It pushes back against it. So the oceans are vast. The oceans are actually too big. So if the oceans are diamagnetic and somehow the sun and moon are creating an electric field and a magnetic field, the oceans are bigger than the sun and moon would be on this flat earth. So the oceans would be moving the sun and moon. They're not, because the oceans are diamagnetic. You know that. Mm-hmm. I mean, you can look it up. So Lenz's law would say the oceans should be moving the sun and moon based on electromagnetics theory. Like you can get a magnet and if you deal with electromagnetic relays, it cannot be the explanation for tides.
I guess depending on what type of charge the moon and sun would have in that theory that I proposed. I mean, to be honest, Ozien, that's my best answer. I couldn't give you an answer as to why those things happen.
How can the sun have an electric field and the moon have a magnetic field and they work together?
Great question. I would love to learn more about it. I'd love to look into it.
Don't you think? When have you ever seen in the real world an electric field coming from the one source and a magnetic field coming from another source and somehow combining together?
Well, I'm not claiming that those two are separate sources, that one is one and one is the other. That's not what I'm claiming.
But in the real world, like real world applications as an electrician, when you deal with power sources, when you deal with generation sources, electromagnetic fields, generators always have come from the same generation source. Always.
Sure.
Right?
Sure.
So like in the real world that we live in, mm-hmm. when we test this stuff, it's always come from the same source.
Sure.
So it would make no sense. So I know what they're doing. I know Shane, right? I've debated Shane. And I know he's come up with this thing working with Robert Bennett. And I've already refuted the claim. I went through his whole presentation. And it makes no sense. I mean, you just think E and H fields are always at 90 degrees, right? E and H mm-hmm. fields, electromagnetic fields that are always at 90 degrees. He's saying these E and H fields are somehow doing this thing spinning around.
Like a toroid field?
But E and H fields don't spin around each other. E and H
That's-
fields are always at 90 degrees to each other.
We're
Always
also,
at 90 degrees to each other.
well, to answer that question, we also have no idea what the sun and moon are.
Well, I do.
How do you know that?
Because I have a theory of knowledge that gives me that knowledge.
4
You
minutes.
mean
I have an
spectroscopy?
epistemology that justifies my knowledge that I know what the sun and the moon is.
You mean spectroscopy?
No. I have a theory of knowledge that justifies what the sun and moon is, which includes satellites that went to the sun and the moon and people that went to the moon.
You have an ideology that you subscribe to.
No, that's not an ideology. It's called epistemology. Ideology is something else from epistemology. So I don't know who you're learning these words from, but they're come to my show and I'll teach you some epistemology. And you can learn your own epistemology so you become a better flat earther.
Ozien, how do you know what the sun is?
We have satellite data that tells us what the sun is.
Okay, take satellites out of it because
Why
there's
would
no
I
way
do
for
that?
you to because there's no way for you to empirically verify that a satellite is really going to the place that you think that it's going to.
Yeah, there is.
How?
I accept testimonial evidence.
Ozien.
Do you accept testimonial evidence?
It depends on who's saying it.
Your other journeyman that you work with.
No. What's the one
You
rule in
don't trust your other journeyman?
What's the one rule in the electrical trade? Don't trust anybody. If they tell you that a circuit breaker is locked off, you don't just take their word for it,
No, you go check.
right?
So you
how
check
did
their
you
data.
check? So how did you check?
You read their data.
So
Does your supervisor come in and make sure, or does he every time? No.
I am the supervisor.
Well, you know what I mean. Your manager come in behind you for every job and make sure you did your job right?
Absolutely.
For every job, really? Does
Well,
his
we're
manager
talking-
come in on every one of his jobs?
We're talking specifically multi-billion-dollar projects.
You know what I'm
I would
talking
hope
about.
So
At one point, there's trust involved.
Well, sure, Ozien,
Thank
but
you.
that was my question to you: is how did you verify empirically that we in fact sent a satellite to the place where they sent it
I just told you I'm not an empiricist.
to? Okay, so you're just believing what somebody else told you.
No, that's not what
Yeah.
that's not my theory of knowledge.
You just said.
That's not my theory of knowledge.
Well, you
I
just said that.
I accept testimonial evidence based upon my justification and my confidence level of their claims. So I have a theory of knowledge. We don't have another 2 hours or whatever it's going to take to explain what my epistemology is, but I do have an epistemology, a theory of knowledge to justify my claims to knowledge, and it's based upon pragmatic naturalism.
You guys have 1 minute left, and I want to remind our audience, smash that like button as if it owes you money. And I'll resume the clock here. 1 minute, and you guys can fight for time.
Oh, that's okay. I was going to quote Harrison, but about how insane the conspiracy theory is that we would go to space and stuff, but I won't do that. I'll let you close out.
Yeah, I do just want to go to Q&A. I'm cool with that.
Yeah.
All right. These guys are gents. They both want to see the time and go into our audience questions.
Oh,
so
Ryan, I'm sorry. Can I just dude, I was reading some of the chat. I just want to clear this up really quick.
Sure thing.
I'll be very brief.
Yeah.
There were some comments in there about how because of where I live, I'm uneducated or whatever. Ozzie and I, we talked about this earlier. I'm not from Kansas. I was born and raised in California. When my wife and I decided to have children, we decided to leave that state to give our kids a better life. And through that move to the Midwest, my wife is now a stay-at-home mom and we can live off my income. 1. 2, somebody was like, of course this guy vapes. And I got my nickname when I was an apprentice. It's because I used to dip tobacco like big old horseshoes. I dipped tobacco for 13 years. And when we found out we were pregnant with our second son, I decided to quit because I wanted to be around for my kids. I don't vape because I'm like, yeah, I vape, bro. No, I'm vaping because I quit tobacco. I quit dipping. So I'm getting rid of that last vice. So this is the last one over. So.
All right. Well, no worries, Big
Hey,
Country.
my-
You don't have to justify yourself to anybody. Don't worry. I'm having beer. I live in Nova Scotia. I had a prescription
Scotia.
before it was cool.
Me? Me and my son are both IBEW too, so I don't know if
Oh,
you're
right
aware of
on,
it.
brother.
Yeah.
Yeah, I am. Yeah, I am.
So I have detached.
I love you in that sense, brother. I love you in that sense.
So we are getting ready to go into Q&A. I have detached my microphone. It is a 1953 microphone. Maybe I should just hang it upside down and say,
Did you say something?
let's
Are
get
you the?
ready
I see your lips
for
moving.
Q&A. You can't see me. That's right. LJ coming in. How do you personally know if it's a spinning ball? That's for you, Ozien.
Horizons, weather patterns, year, seasons. My mom told me.
His mom told him. Any thoughts on your side over there, big country?
No, it's a great answer.
All right. Mama told me there'd be days like this. All right. There you go, LJ. All right. LJ coming in again. Why doesn't Earth spin under a hovering helicopter?
Um, it does not because it maintains the same momentum. It's called law of inertia.
Any
I don't
thoughts
have
over
my
there, big
video.
country?
So, are you suggesting that the atmosphere is in lockstep?
No. There it is.
But you just said it was.
Huh? It moves with the Earth, but you still have Coriolis and weather and all types of stuff.
It is in lockstep.
You still have Coriolis and weather and all that stuff.
Okay, gotcha.
All right. Let's carry
By
on.
the way, my brother was AT in the Navy as well.
Oh, cool.
Oh, maybe not. Go ahead, Ozien, if you want to comment.
Oh, I
All
just showed a video of a helicopter taking off on a flight deck of an aircraft. I took off on a helicopter off a flight deck of an aircraft carrier, so they do fine maintaining their position with the aircraft carrier.
All right, let's carry on. Thanks, Ozien. And also, I do want to accentuate that we do appreciate everybody who has put in for our super chats as well. If you have other questions related to the subject, as Ozien does a screen share, you cheeky little bugger. If you have
You don't have to
questions
share
related to the subject, get them in now. We are going to be reviewing the super chats as we go through. So Kango44, big country, instead of all the bullshit they say, please show your measurements of flat Earth. I put my parental filter on there. You see that?
No, you can have said it's fine. I don't have the measurements with me, but I'll definitely bring them for the next one for sure. Yeah.
Any thoughts on the other side, or do you want to just carry on?
That's what I would want, but I still wouldn't believe them.
All right, Earth is Life says, all right, BC, what is the difference between plane and geodetic surveying?
Yeah, geodetic surveying is plane surveying wrapped around a ball with a presupposed radius value and then a fluctuating mean value.
Any thoughts on the other side?
Geodesic. So planar surveying is approximation. Geodesic surveying is accurate based upon like the gravitation of the Earth. So it precisely measures the curvature of the Earth.
Do they take a weighted mean?
I'm not a geodesic surveyor.
The answer is yes.
All right. I think that's where we're going to wrap up that super chat. Thank you so much. Earth is Life. We appreciate you. And we appreciate, once again, everybody in the super chats. I want to remind everybody, if you put in a super chat, you will have a question for one of our speakers and be able to carry on our discussion. So, Earth is Life. Ooh, somebody said I was a little low, so I'll try to speak a little more into this old 1953 microphone. So, let's see. LJ says, at what size does ocean and seawater start to curve?
Immediately.
Any thoughts on the other side?
Sorry, Ozzy, I didn't hear what you said. I was texting my wife. I apologize.
I've
worries.
never seen level ocean or seawater, and I lived on the ocean for several years.
This is the question was is at what point does it start to curve?
Immediately.
Okay. You must live on a different ocean than I've ever seen.
I lived on it. Like, I've never seen it level. I've never seen it flat. It's always been curved. It's always been like
Yeah.
All right, let's carry on.
sometimes.
Earth is Life asks another question. Thank you so much, Earth is Life. BC, what about the high altitude balloon and rocket footage that don't use distorted fisheye lenses?
I haven't seen any. And I can show you a high altitude balloon footage of I forget how high. I want to say it was like 110,000 feet. It was a dog cam footage that showed a flat horizon. So I have not seen one. If there's one specifically that you could cite, we could look at it. But it's like a broad question of a what if.
Any thoughts over there, Ozien?
Yeah, I mean, the great pressure gradient of the Earth proves that we're living on a globe. We have satellites. We have balloons that show curvature at high altitudes. Earthrise from the moon. Tons of proof.
I'm laughing. LJ, this is a little bit of a silly question. Maybe something straight out of the childhood. If you dig straight down, will you come out upside down? Yeah, yeah. You dig far enough, and you just, burst into China. That's what we were talking.
You would
Go ahead.
die. Well, according to Witsit, you would run into the block domain wall or whatever that is.
All right.
Well, we have no
Um,
idea, right? I mean, because we've only dug 8 miles.
you would die from the. You would die.
All right. Thank you, everybody, for having some fun with the super chats. Honestly, thank you also to Ozien and Big Country for answering all of these questions. Honestly, these questions are from earlier, so if any of them seem a little bit outdated, just let me know if we've already touched on these subjects. So, let's see. Kango 44. Ozien's intro is all flat Earth people deserve. Kango, you know me. I'm no bully, so I'm not going to say that as you put it. But yeah, Kango really appreciated your intro there, Ozien. So LJ, and I was gonna say LJ is coming after you, Ozien. Why don't we have footage of eclipse shot from space?
Eclipses are about an Earth alignment with the moon and the sun. So, depends. Like you'd have to be aligned with the moon and the sun. And we do see like the shadow of the moon on the Earth. I don't know. I don't care.
Thoughts on the other
Pay
side.
what the LJ instead of buying super chats, pay somebody to go do it.
Pay somebody to go do it. Well,
No, keep the money in house. Come on.
Yeah, true.
Yeah, stop that. Yeah.
After show on matters now.
Oh, okay. Well, if you're gonna do that, well, no, LJ, I don't know if you've ever hung out over on the after show, but there will be an after show, obviously on Matters Now, as Ozien has just put it. I don't mind pitching that out there for you, buddy. And I'll also, Big Country, if you had any other thoughts before we
Nope.
close out.
We can rapid fire too. My wife's calling for reinforcements, so
Oh no! I was gonna say I know you have
I
a
hear
young one
that.
there. I've been there. Yes, indeed.
yeah, he's
So-
ripping up styrofoam in our room currently. So she's like, "Come help."
Oh
I've had
man, well,
worse.
better than ripping up a diaper. All right, all right.
It's true. It's true.
All right. Speaking of ripping up a diaper, a question from Butts in Your Face. That's the name of the super chat.
Good name.
Everything all together is not working out. All right. Someone tell Ozien the Tides debate was last week. You know the one you ran from against Shane.
I didn't run from anybody. The people were trying to promote me, and they blocked me from their Discord server and called me names. I personally don't have a problem with Shane or Jaren, but I wasn't going to allow them to make money on me just to insult me and like be toxic about me. And that is either cosmology, where they were coordinating with Witsit to ask Witsit questions in the last debate they had with me on modern day debate. If you want to make
Hold
that
on,
claim,
Ozien. Hold
calling
on.
me names, insulting me, making fun of my Twitch, all types of stuff.
You know how we roll here. We can only. You want to talk about that on the after show all you want, but we don't want to stir a super pot here as far as the speakers that we have on modern day debate. But I mean,
What was the super
honestly,
chat question?
I know, but at the same time, I'm torn because every once in a while we do stir the pot of drama on modern day debate. That's sometimes how it just naturally flows as the conversation goes. But I do want to refrain from talking about speakers that we generally have on the show, and I know you understand that, Ozien.
Well,
So
Shane is afraid to come to your show, so.
Oh, well, Shane, don't be a big crybaby. I don't know who you are, Shane, but
Shane
don't do
St.
it.
Pierre, either cosmology.
Someone's gonna clip that. It's gonna be bad. All right, Kango44 asks, all right, Big Country, why is it harder to carry a weight up a slope than along a flat surface?
Because it's heavier. I've heard this question before, and I don't understand the relevance of it. To be frank.
All right, another one coming in.
Galileo
Sure.
law of inertia that was clarified by Newton.
Okay. Kango44 asks again, Big Country, given a 5 kilogram mass, 2 meters off the ground, impulsed with 90 newtons horizontally, tell me where the mass will land using your understanding of forces. This is a very simple problem.
I couldn't even begin to answer that question. Also, why do you got to ask questions in metric, dude? I'm an American.
I know.
We use American standard. I don't kilograms. I don't know. I don't know the answer to that question. I'm sorry. Just being intellectually honest.
I was to say, I was just hiss as a Canadian. One metric. All right, Canadian. So Kango
Metric
44.
is cool for like sockets, and that's about it.
All right, Kango44. All right, so Big Country asks, look through a glass with a pencil in it. Because the pencil looks like it's in a different position, its actual location ceases to exist. Try some thinking. Oh no.
Oh,
I
the
don't have any
label's
water
blocking
in
it.
there.
Yeah, that's the idea of
need water in
refraction,
there.
right? Passing through
Ozien,
two
we didn't
different
ask you
mediums.
to stick your wand in a thing. Ugh. This isn't what we asked for.
You're being
So
dirty.
sorry. All right, now, all right. Well, I don't know if we're gonna get anything out of that, but if you guys want to actually engage with the discussion, go ahead.
Yeah, no, I'm not denying anything that he said there. It's the idea of refraction, right? Light traveling through two different mediums.
All right.
Test it. Isolate the IVs. Bury each one.
In my
I'd love to see
defense-
that. I still want to see the test of pressurizing gas without a container using only gravity.
Send a balloon up. You can do it. Test it.
So I was gonna say,
No barrier.
in
And you
my
can
defense,
pressurize gas
guys-
up there?
Actually, you
There's
guys
no
carry on.
container. There's
Next
zero
one, guys.
There's zero atmospheric pressure. You can go take a flight up there. There's zero atmospheric pressure.
Ozien, you're only dismissing it because you know the answer is we can't test it.
No, you can go take a air flight up there.
You can't pressurize gas without a container using only gravity.
You can
know
go
you
to zero atmospheric pressure, take a flight. There's no atmospheric pressure. It's vacuum. It's a vacuum. You can take not a commercial flight, but you can charter a flight where there's zero atmospheric pressure, or send up a weather balloon, measure the vacuum of space, and you won't find any container. There's no container. Go measure it. There's no container.
It's still not what I asked. That's okay.
So it's
though.
not
That's
the
all right.
antecedent of the Earth does not require a container.
All right, we got to carry on just because Big Country's got some parental issues that he
That's true.
needs to move on to. He's about to rotate shifts. We all understand.
My
Hopefully
feet
for the
are
pranks.
swelling too, like an old lady,
All right. So, Screwy Louie.
old man.
Screwy Louie asks, Ozien, you accuse me of such foul language, but Screwy Louie was the next super chatter, and that's why my mind was in the gutter. Question for the flat earther: how many people do you think are involved in the globe deception? As the number greater or lesser than 1 million? Give your best
Maybe.
guess.
Maybe. Yeah. How many people do you think were involved to shut the world down for the flu 4 years ago? Was it more or less than 1 million? Because they convinced everyone to stay indoors. It's kind of a silly question. How many? The exact number? I don't know.
You're skirting around that one really well. I appreciate
You like that? You like that?
honestly, that's pretty good. As far as skirting, Ozien, any thoughts?
Yeah, I reject the whole premise of his argument. Like, okay, if it was like, okay, there's so many other ways we can waste money. Like they have black projects, they just do it on a war of terrorism. We can waste billions and trillions of dollars. Just say there's some terrorist in Afghanistan and Pakistan, and just pretend like we're going to go
We
find
do
the
that.
guy.
We already do that. Yeah.
Why don't we just say there's the Van Allen belts? It's impossible to go to space because we'll die and fry. And why even pretend like we can even send anything into space? It's like the dumbest conspiracy theory ever. Just pretend we can't go to space.
All right, you guys are
I
gonna
already
need a
do.
minute to expound on this, I think. So let's
I
kick
already
it back to
pretend
open
like we.
discussion.
I pretend. I already pretend like we don't go to space.
No, you pretend like it's a conspiracy
it
that
is,
we
though.
go to space.
Correct.
Why wouldn't they just say why wouldn't they just be honest that we can't go to space and just hide money other places?
Well, because
why
then they
create
would.
a NASA program to pretend like we're going to space? Just say we can't go to space and spend the money on black projects.
I think
Why
that's what
lie to
NASA
us?
is. I think that why lied? Come on,
Why
Ozien.
lie to us
Why would
about
the government?
space? Why
Well,
not just say we live in a prison planet?
Well, for two reasons, right? And this is just a hypothesis. I have no idea why psychopaths are psychopaths, right? It's why asking like why habitual liars habitually lie. My belief is that the whole intention of this is to hide the existence of God. Now,
Satan created prison planet. Wasn't that more hiding God than
no,
vacuum
Satan
of
is the
space?
ruler of prison planet. There's a difference. He's the king of this world.
Space isn't prison planet. Space is like freedom.
Yeah, but you can't get there, which means
we
which also would mean in turn that the idea that we were all created from a single cell organism, which there's no fossil record of that whatsoever. That
Well, it
whole
wouldn't be a
paradigm,
fossil record for that.
well, there's no fossil record of any any evolution from one species to another species.
Yeah, there are.
No, there,
tons.
Ozien, stop.
Thousands and thousands and
There's
thousands.
thousands and thousands.
Thousands and thousands and thousands and thousands. Most Christians
like one species to another species. What is you're saying that right now?
Most people that believe in evolution are Christians.
Sure, they're retarded. Most Christians believe in the rapture.
Hear that,
too.
Christians? All the Christians watching this that believe evolution is true?
Retarded. Most Christians that believe in the rapture, retarded. And I consider myself a Christian, not according to the current dogmatic aspect of Christianity as the religion.
Me, the atheist, I love you all, man. I don't care if you're a flat earther. I don't care if you believe in evolution. I don't care if you don't believe in evolution.
Oh,
yeah, I didn't say that. I didn't say that I hated them.
Guess what? Evolution doesn't falsify God. Abiogenesis doesn't falsify God. Even William Lane Craig doesn't believe abiogenesis falsifies God.
I'll leave for 1 second. Y'all can't behave yourselves.
You gave us a minute. You gave us a minute.
I swear. Yeah, I swear. All right, LJ coming back in. Globe lie could be controlled by less than 100 people.
Sure, I'd agree with that.
Well, I'd have to be one of the liars.
No, Ozien, I don't think you lie. Because lie means that you have like an intention to deceive. Like this is like it's premeditated. I don't think you're lying because you're getting like a paycheck from NASA. That I wouldn't consider you a liar.
I've measured curvature.
Okay, you might be lying there. Yeah.
I'm not lying.
Did you say you did that again? You said you counted the pixels or something?
Yeah, it's one way of doing it.
Gotcha.
Right. So Chris G, a member, said my stream froze. Yeah, I'm not sure what happened there. There's been a couple little glitches here and there. Unfortunately, there was a little transfer from me and James doing me streaming from here and him streaming for the live event we had the other day. If you didn't see the Minds Fest event that was just hosted on Modern Day Debate, check it out. Kango 44 coming in. Big country. The pressure differential under an airplane wing is higher than surrounding air pressure. That's lift. Is an airplane wing a container?
The answer is no. But do you mind if you give me a screen share for just 1 second?
Sure thing. Just pop it up, and I'll have you good to go
Cool.
right now.
Oh, Christ almighty. How do I do that?
Just open our Zoom chat, and you want to hit screen
Oh.
share, and then just select the screen you want to share out.
Okay, hold on. Because my thing popped out.
No worries. Let's
There we
check in
go.
on how
I
many
got it.
people are watching while you get that up. So, once again, we got 500 people watching. We got less than 200 likes. Hit the like button, everybody. We really appreciate it. Get this boosted out in the algorithm. The more people that see this, the more people that are going to get to see these arguments live on screen. Nobody's going to get to claim that we have censored any arguments here on Modern Day Debate. We always want to provide an open, neutral platform. Your screen share is up and running.
Perfect. Yeah. Okay, so this is the 1988 derivation and definition of linear aircraft model from NASA PDF in the summary right here. This report documents the derivation and definition of a linear aircraft model for a rigid aircraft of constant mass flying over a flat, non-rotating Earth. If you'd like another one. Oh, I can't. Why does it do that? Oh, there we go. And this one here is from aerostudents.com. This is flight dynamics summary, making some assumptions. In this summary, we want to describe the flight dynamics with equations. This, however, is very difficult. To simplify it a little bit, we have to make some simplifying assumptions. We assume that there is a flat Earth, there is a non-rotating Earth, the aircraft has constant mass, the rigid body is symmetric, there are no rotating masses, and there is constant wind. So my question would be is why do the bodies that fly aircraft assume that we fly over a flat non-rotating Earth?
That's a good question. The answer the first part of that would be no aircraft has a perfectly rigid body. They just assume it does. So they make all these assumptions to simplify the math because engineers like to dumb it down and make it simple. And then they let the field guys figure it out in the field. So they just simplify it to make the equations easier. So aircraft frames are not perfectly rigid. They have flex when they fly. Wings flex. They're not perfectly rigid, right?
Sure. Mm-hmm.
So one of the assumptions, the first assumption, where they say it's a rigid frame, right? We falsify.
It's actually the third. It's the third.
So one of the assumptions is not true, right?
Well, this is an ad hoc rescue fallacy because now what you're saying is you're diminishing the point by saying that the bodies of NASA and aerodynamics students are being taught something in reality built on a paradigm that is not real, which is a flat, non-rotating Earth.
It's not. It's not because they're actually taught the truth also.
Oh, okay.
Yes.
They just write papers on and test it on a fact.
That's not a paper. That's not a paper.
The 1988
That's
NASA
not a
document,
paper.
It's not a paper?
It's a document. It's not a paper. It's just an explanation to simplify a concept to teach people. So here's another thing.
On a paradigm that doesn't exist.
Yeah. It says these are assumptions to simplify the concept, right?
Based on a paradigm that isn't real. Why don't they just say that we assume that the Earth is a pumpkin?
Can you explain how it's a fallacy to point out the point that so draw this out to me. When I point out the fact that it is an assumption to simplify the concept, and I point out one of them, And you're trying to say that it must be true. So they're saying we're just going to assume these are true
Mhm.
to simplify the concept. That means that these concepts are true, are concrete. What fallacy is that called when you assume a concept is a concrete? Do you recognize that fallacy?
I don't.
It's a reification fallacy.
Oh, okay. Yeah.
Yeah. So are you committing a reification fallacy?
Mhm, mhm.
Yeah. Okay. So let's not. If we're going to
Oh, no, no,
throw
no.
out fallacies,
I'm not.
yes, you are.
No, I'm not.
You are.
No, I'm not.
When you're taking a concept and
The
seeing it as
concept
a
of flight.
concrete, no. The assumptions they're making are concepts they're going to assume are true for the sake of the explanation to simplify the understanding to explain it to other people. But they're saying these concepts aren't true. We're just going to simplify it, like the concept of a rigid plane, because what it is, it's impossible to make a rigid plane. It's impossible.
Mhm,
No material is perfectly rigid,
mhm.
especially when you bolt them together. The Earth is flat like because it curves 360 degrees over 40 million meters.
Okay, so why wouldn't
40
they
million
just
meters.
why wouldn't they just teach all their students that, hey, the math is going to be really tough, but since you're all getting degrees in this, let's make sure that we do it the right way.
Where does it say that's for a degree?
I'm not saying it's for a degree.
Then
That
why say
specifically is
that?
for a degree.
Then
But
why would you
these
say that?
people are learning about flight and aerodynamics of airplanes, and they assume that they are flying over a flat, non-rotating Earth.
I know aeronautical engineers. They learn spherical geometry. They learn the globe model. They learn how to make airplanes that fly over the curved Earth. Matter of fact, attitude indicators are made. Actually, modern ones have sophisticated equipment now. Attitude indicators I worked on as an avionics tech have corrections that correct the attitude indicator for horizontal, that correct it for the curvature of the Earth. Inertial navigation systems, the accelerometers and the gyroscopes for the inertial navigation systems have corrections in it for the curvature of the Earth. When you move to a new theater of operation, like when we go from Norfolk, Virginia to the Mediterranean, you know what we have to do? We have to go reset the inertial navigation systems to realign all the gyroscopes on the aircraft carriers to make sure they're level for the new theater of operation. Because guess what? We went over a big, huge curvature of the Earth. We had to do all that stuff because we live on a globe. Like, I know it's a globe because I worked on all this equipment that only works on the globe. LORAN only works on the globe.
Last word
GPS
for
only
big
works on the globe.
country, and then the next question for you as well.
Nope, we're good.
All right, Kango44 says, big country, gas giants that are clearly visible with a telescope are a good example of gas in low pressure environments without a container. Can find Saturn's container.
How do you know what those are? You just making a claim that the gas giants are gas giants because we were told that they're gas giants. So, there you go.
All right, let's move on. Earth is life, a big country. If there is a container above Earth, is it a solid container? If so, why can't it be detected by radar?
Sure. What is the container? I have no idea if it's a physical or plasma or something like that. The star trails that we observe on the equator, how they look to be in straight lines depending on where you're standing, versus north of the equator, how they appear to move in one direction. Star trails in the south appear to move in another direction. This can actually be replicated with something like a dragon's eye, or it's like an acrylic half dome that you can just put over a picture of star trails, and it would actually give you that perception of different direction of the star trails. But all stars move east to west. So.
All right, let's carry on. Thank you so much, Big Country and Ozien, for being here. We got a couple more super chats to go, and then we'll get our speakers out of here with their closing statements. Esteban Ilbaca says, Big Country, pressure goes from zero but is plus everywhere in space. The only container for it is the universe itself. The gradient is only due to the fact the atmosphere has weight and stacks on itself. Simple. It's from Esteban.
Yeah. I get what he's saying there, that the universe is the container, but how would you even prove that? How would you verify that claim? Can't.
Any thoughts over there, Ozien?
No, perfectly explained. We can do Earth, Moon, Earth bounces with ham radios at 237,000 miles away, which means there is no container.
All right, let's carry on. And thank you, Esteban, for your super chat there. Kango44 strikes once again for another super chat for you, Big Country. Put your hand in boiling water, and will it burn? Put your hand in air at the same temperature? It won't, because air is a lot less dense. Seemed like a dramatic super chat, so I did it justice, I think.
So it's like
Very dramatic.
212 degree Fahrenheit air versus 212 degree Fahrenheit water. So your hand will burn quicker in the water because it's more dense, more concentrated
Sure.
against your hand than like a hair dryer at 212 degrees. So that's what he's trying to say. If you go up to the thermosphere, even though it's like these massively high temperatures, there's no air to blow like even a hair dryer. Like, so like it's not like sticking your hand in boiling water. It's like sticking your hand in no air. Like there's no like air there's no wind to even blow to even heat you up because there's no real molecules. The word I was looking for was excited. The molecules are excited, which is what heat is, when the molecules get excited from the radiation from the sun.
I get you.
All right.
Sure.
All right, it is time. Every time we have this debate, LJ is going to ask the question, and you have to be ready. Share your screen with real, non-CGI footage of space. Ozien. LJ is coming at you.
He wants a non-CGI footage of space?
I think this is like a staple question for LJ. Share your screen with real non-CGI footage of space.
He's seeing one right now. I live in space.
All right.
Earth is in space. I live in space. This is a non-CGI footage of space. That may sound pedantic, but that is just a fact. I live in space. I live in a pressure gradient. I live in space. I would be considered a vacuum compared to Uranus. I said that like purposefully incorrectly.
Well, without the screen share, LJ, let us know your thoughts, because earlier at the same time, LJ also asked, why are the stars and satellites always missing, seemingly, in these non-CGI footages of space? I think he's tagging on to his last question there, Ozien. So, if you want to,
he's asking why there's no stars.
Why are the stars and satellites always missing? From LJ.
There's stars sometimes. You can see stars when you look at the ISS. You can take pictures of the ISS and there's stars in the background of the ISS. You can take pictures of the ISS from Earth and see stars. You can see the ISS crossing the moon and see the moon. So yeah, you can see the ISS from the surface of the Earth and see stars. So there.
All right. Let's carry on.
Does he want a screen share? Like,
he really does. I know.
well, I can show a screen share if you want me to. Like,
if you want to put up your screen, that's cool.
ISS from Earth.
But what I'll ask is if you do a screen share that you let LJ, sorry, not LJ, LJ's the super chatter, you let Big Country respond to some of the things that you've been saying here. Even though
Okay.
LJ's always very keen in the chat, he's going to be coming back at you. You know he will, Ozien. So we'll let Ozien get that up. But did you have any response?
I don't
Big
know if
Country?
I have one ready available, but
Yeah, there's I think what he's specifically asking is when they take pictures of satellites in space, that there's no stars in the background. I think that's what he's asking. Just keep it, just
okay.
keep it rocking. Just keep it rock. I gotta.
I think
yeah,
I
Keep it
found
rolling.
one, but I only see one star because he zoomed. Oh, I see two stars next to it. But I mean, it's not a very good picture because they're zoomed in. I can't find it now. Anyways, it's hard to find one. I'm not prepared for it.
no
But I
worries.
found one. Oh, I can share this, I guess.
All right, let's keep it quick, just for the sake of our other speaker here.
Yeah, I don't know why we're sharing. Anyways, I don't want to. Hey, can you see it? There's like two little dots. It looks like stars. If that's the best picture I could find at the time you gave me. Two little dots. I don't know if you can see it on the screen share, but that's what I got. Maybe there's other ones, but I'm sure somebody can find one on Discord somewhere. But anyways, two little dots on here.
We can see
One,
that.
two.
Let's
Okay.
carry on there, Ozien. And thank you. Also, Big Country. I know you said you had to go there earlier, but we've just been carrying on. Honestly, I've been going way too long today to myself, so you can hear. I've got to get to bed soon, too. I'm sorry, Wilson says, why is it that from Ohio I can't buy a telescope and see Mount Everest?
You can't see forever. I don't know why this is a constant question on these debates. Of course, you have things like dust, debris, smog, atmosphere conditions of the day. Can't see forever. It's due to perspective. There you go.
All right. Let's carry on. Witsit gets it. Thanks, Witsit, for your super chat there. Ocean's waving to you.
Shout out Witsit. Hit me up, homie.
Everybody's just having a moment. Yes. Witsit gets it asks, Ozian, can you attribute physical proprieties to conceptual abstractions? Yes or no?
If it's purely conceptual, no. But if it's an axiom or what do they call it in science? I just had it like yes, if it's an axiom and like Bell's theorem, and we do a test and we verify if Bell's theorem is supported, the axioms are supported, then it gives justifications for those axioms to be true, which is those conceptual things to be true. I don't know why he asks me this every time,
All
but
right.
yes.
Well, he follows
So,
up.
and we gave a Nobel Prize for that.
He follows up Ozian, and he says, also, what would you accept as falsification of the globe?
Falsification for the globe. Pictures from space of the flat Earth.
All right.
Or the outer lands. I'll tell you what, take me to the outer lands. Take me to Narnia.
All right. Take Ozian and Narnia, and you will have him. Witsit gets it follows up, and he says, ever find a real picture of Antarctica from space?
Tons of mosaics because the satellites do polar orbits and they are lower altitude. It takes it's harder to insert satellites into polar orbits due to the forces involved because of the gravitational forces.
All right.
Yeah.
Before we move it into our 1-minute closers, Melissa Schultz, last question. What can I routinely see? Why can I routinely see boats 20 miles away from the beach on the Great Lakes? Should they? Sorry, I got to pad this a little bit because there's no I'm sorry, Melissa. There's not a lot of pronunciation. What can I routinely see boats 20 miles
Punctuation.
away from the beach on the Great Lakes? I should be 200 feet below the curve. I use marine traffic for location of boats.
I'd have to see her measurements. I'd have to see her altitude. I'd have to see the height of the ship. So some of those ships are like 100 feet tall. If you're a couple hundred feet in altitude, that's going to go into the curve calculation. You also have atmospheric refraction. It seems hard because a lot of times at Great Lakes, it depends on the time of year too. Weather conditions, they're pretty like foggy a lot of times. I'm surprised you can see that far anyways, but I guess some conditions you can see like 80 miles. You can see like I think like the Chicago skyline sometimes. Like it's like 60, 80 miles away due to refraction.
But that's a mirage, Ozien, remember? Remember the
Yeah,
talking point? That's just a mirage.
sometimes.
I want to give Big Country some
That's
time
due to
to respond.
refraction.
So, any thoughts on this
Well, he was
question?
asking me a question. He asked me a question.
I understand.
He says, right, Ozien?
You responded, and if he has any follow-up, let's. I just want to let him know that he has some time here if he wants to respond. If not, we'll move into the 1-minute closers. So
Yeah,
Big
no,
Country.
I say that's a big contention for the globe here is that obviously there's plenty of times where we can see too far. So short and sweet.
All right. Anything lastly to say, Melissa Schultz there, Ozien?
No, I'd be interested in seeing the observations.
All right.
Thanks.
As per usual, you know me, UK style. Ozien, 1 minute on the floor. Your closing thoughts on our discussion this evening.
Yeah, I think the diversity of life is best explained by us existing in the Goldilocks zone. I see no explanation for why we have a pressure gradient from the flat Earth. I see no explanation for how we get heated up, how we cool down at night. I see no explanation for how the laws of thermodynamics could even be possible on the flat Earth model. I see no explanation for the day and night cycle, the seasons, why the sun sets, why the sun rises. No explanation, no explanation for tides, no explanation for why even fish exist. Why do fish exist? How is it even possible for humans to live on the flat Earth? Like, I don't think it's possible. I think we would either overheat and die or freeze and die. I think we'd be a frozen wasteland, actually. We'd be heat death right now due to the law of thermodynamics. And that's it.
All right. Well, thank you so much, Ozien, for your closing statement. We're going to kick it over to Big Country. You have 1 minute on the floor. Your closing thoughts on the statement or this discussion and where everybody can find you, of course.
Yeah, man. Thanks so much. Thank you, Ryan, for hosting. Ozien, appreciate you debating tonight. We kept it pretty civil. Thank you for not rage quitting. That's cool.
Big props on that.
Based on the last one, yeah. But yeah, so this is a fun conversation. I enjoy doing these. There's only so much you can talk about with so much time. But obviously we talked about a lot of different things. Still waiting to see that test of pressurizing gas without a container using only gravity. So maybe we'll see that in the future. But I'll wrap it up real quick because I do have to go. But I believe I sent the link tree over to James to him to put in the description, but there is a link tree, linktree.com/WB Conspiracies. That has all of our links. We do 5 different shows, 4 that I'm involved with. We have like a store where you can buy shirts. I'm wearing a shirt. This is my hat. We all designed all this stuff. So I'm really cool there. Currently working on actually creating a game studio. I'm designing my own video game too. So stay tuned for that. But doing a lot of different things. And thanks so much. Hopefully we'll do it again. Maybe a different topic next time.
What's the genre?
Awesome.
One of them is the game that I'm working on is like a conspiracy game, sort of like you find out that your family is actually in the secret society. So like I guess it's a conspiracy. And then the other one is like a remake from a Sega game from '93. It was called General Chaos. It was like one of my favorite games. I'm just remaking that with Unity. So stay tuned.
Cool.
Awesome. Awesome. It sounds like we probably grew up on the same genre of games. I know me and Ozien appreciate similar games as well. So,
Hell yeah.
yeah, we can chit chat about that in the after show, or if you want to hang out on the Zoom afterwards. I appreciate everybody here at Modern Day Debate hanging out in the live chat, as well as Ozien and Big Country for having this discussion. If you have and yeah, if you haven't already, hit the like button. Share this out in those contentious spaces where you like to have those live discussions. Honestly, I've got to get myself to bed though because I was up till like what 3 o'clock last night screaming rock and roll. You know how it goes for old Rye here. Uh, Doing all my Led Zeppelin nonsense. So I got to get out of here and just. Blah. And good night, everybody.
Night.
There we go.
No matter what you think of me, it's only half of what I am. I'm the greatest, I'll set you free to stand, and I won't give a damn. I expect complete conformity or I'll cast you. I spit upon your decency and swallow up your pride. I must mean everything to you. Hear my call out to war. The fake news says now I'm a god who lives forevermore.
All right, honestly, hit the like button. If I'm gonna scream my little booty off like that, why? Why are there so many people watching? Stay up late. Stay up late the night before. James was at a live event doing the Minds Fest. Honestly, I would like to see if all of you in the live chat, I'm going to put on some music. I would like to see if you guys want to let me know who has watched the Minds Fest debates and also who is on their way over to watch those Mindfest debates. But yeah, old Rye's gotta get bed. I gotta get to bed, guys. I'm dead. All right. So enjoy listening to me scream at you at these high volumes. But we're gonna be back tomorrow and the next day for more live debates. It's gonna be great. I'm gonna get myself rested up, and hopefully I won't be the only one screaming on screen. All right. So make sure you hit the like button. Appreciate it, guys. Good night.
No matter what you think of me, it's only half of what I am. I'm the greatest, I'll set you free to say and I won't give a damn. I expect complete conformity or I'll cast you aside. I spit upon your decency and swallow up your pride. I must mean everything to you. Hear my call out to war. The fake news says now I'm a god who lives forevermore. Now that I'm everything to you, you might call out to war. The safe news says now I'm a god who lives forevermore. all of my life, living in a world of regression. Tyranny's mixed with self-oppression. What am I to do but tear away when I'm boiling at the top? Try to find a way to fight the fire, smart to rap from the minds of liars. Call the shots as you bow your heads, and the march never stops. The stars could be free, but this insanity bends you right by the knee. Running in circles now for something that can't be found. And I bet as you hit the wall, the rain starts to fall. You can run away, sing a tune that's true. I'll be beside you. Who's the one that holds you down? Push through there in your way, anything to make you stay. Cut the strings before your life starts to decay. From tears of blood, regrets of laughter, turn around as your heart beat faster. You hollow shape as the faith begins to drop. Shelter can find your thoughts of suicide. It's hanging down by the fray. Running in circles now for something that can't be found. And there's no time for today. You prayed away, the world would be untrue. I will rise against you. I can't see there is no time arranged. We've enraged our senseless minds until they're gone. Nothing can matter at all. Well, the stars could be free, but this insanity bends you right by the knee. Running in circles now for something that can't be found. Out of breath, smash the wall, the water consumed all. You prayed away that the world would be untrue as it rose against you. It's all here, but will you try? The pain unveiled through genocide. Until we're gone, nothing can matter at all. When you're gone, nothing can matter at all. Did you think it would always be for free? Now sit back, watch it burn, burn, burn.